All right, in today's lesson, we're going to be entering Chapter 4, and today we're going to do Section 4.1 on classifying triangles. And so if you haven't done so already, this would be a good time to get your notes out and get some paper out to take some notes on and to do a little work on. We can pause this video while we're waiting on everybody to do that. Okay, so we should be ready to go now. Let's begin with a few warm-up questions from some of the things we've already done. First question, what is the special name given to the pair of angles shown by angle 2 and angle 6? You can pause right here and take a moment and answer this question. Okay, so in our last chapter we learned several different names for pairs of angles. In angle 2 and angle 6, since they're on the same side of the transversal, and one is on the interior and one is on the exterior between of the lines, we would call those, and they also have different vertices, that's important, we would call those corresponding angles. Second question. Find the measure of angle 3, and note that measure of angle 8 down here has been given to us as 118 degrees. So with that angle, we should be able to find all the others since the lines are parallel using the relationships we learned in our last chapter. So take a moment and find the measure of angle 3. We can pause right here. Okay. Measure of angle 3 should be 62 degrees. We talked about how every angle on here, when we have two parallel lines cut by a transversal, every angle on here is either congruent to every other angle or supplementary to it. Here we can see that angle 7 would be supplementary to angle 8 since they form a linear pair. So angle 7 would be 180 minus 118, which is 62. And then angle 3 and angle 7 are corresponding angles, so they would be congruent. You could also say angle 6 would be supplementary to the 118 angle, and then angle 3 and 6 are alternate interior angles, making them congruent as well. Okay, next question. We're going to find the measure of angle 4 given the same situation. We'll pause for just a moment while everybody answers that. All right, we can say that angle 4 would be 118 degrees since angle 4 is a corresponding angle to angle 8, which is 118 degrees. And now we want to find the slope. Okay, so to find the slope, we're going to use our slope formula, which says that the slope, which we use the letter m for that, is equal to y2 minus y1 over x2 minus x1. And we'll substitute in our values. So if I let this be, let's let this be x1 and this be y1, then this will be x2 and this will be y2. And so substituting in those values, we'll get negative 5 minus 4 over 2 minus 4, and that gives me negative 9 over negative 2, and the negative over negative will cancel and give me positive 9 over 2, and so my answer is choice D, 9/2. One more. I'm going to write the equation of the line in slope-intercept form. It has a slope of 3/4. It contains the point 0, 5. So we'll pause here and take a moment to answer this one. All right, so in our last chapter we learned this point slope formula, which says that we can write the equation as y minus y1 equals m times x minus x1. Sorry, this looks really messy. So if we let this be our x1 and this be our y1, and then this is our slope, which is m, then we can write the equation as y minus 5 equals 3/4 times x minus 0. And to put that into slope-intercept form, which is what we've been asked to do for the for the answer, I need to distribute to get rid of my parentheses and then just add the 5 to both sides, so I isolate y. This x minus 0 is just x, so I can really just drop the parentheses and make that 3/4 x, and then add 5 to both sides, and we get y equals 3/4 x plus 5. And so that is going to be answer choice C. Okay, so that's the end of our warm-ups for today. So let's move on into our lesson. In the past, we've talked about different types of angles. We've classified angles as acute angles, right angles, obtuse angles, and straight angles. And today we're going to move a step further, and we're going to be focusing on triangles. And we're going to learn some phrases or some words that we can use to classify triangles based upon their angles and also based upon their side measures. So let's look at first, how do we classify triangles based upon their angles? There's 4 different words that we can use to classify a triangle, and any triangle can be classified as one of these. When we have a triangle, it could be, when we look at the 3 angle measures in the triangle, it could be that all 3 of the angle measures are all acute angles. So if I've got that this angle is an acute angle, and this angle is an acute angle, and this angle is another acute angle, then we would refer to that as an acute triangle. Remember, an acute angle is an angle that measures less than 90 degrees. So if all 3 of these angles are less than 90-degree angle measures, then we have an acute triangle. Let's skip over this one for a second and go over to this one. If a triangle is an obtuse triangle, then it turns out that it has exactly one obtuse angle. Remember, an obtuse angle is one that's measure is more than 90. And a triangle can only have one obtuse angle. It can never have more than one. So if I've got this angle here, which is the one which would appear to be an obtuse angle, if this angle measures more than 90, these other 2 angles are still going to be acute angles. But as long as we've got one angle that measures more than 90, so we've got one obtuse angle, then this is classified as an obtuse triangle. And if we have a triangle that has exactly one right angle in it, as this one does, and a triangle can never have more than one right angle, it can only have one, then that is a right triangle. Now, one we skipped over is an equiangular triangle. And the word equiangular basically is equal angles, if we break down that word. And so if I have a triangle where all 3 angles all have equal measures, which means the 3 angles are congruent to each other, then we have an equiangular triangle. And it turns out that when that happens, that all 3 of these angle measures always have to be 60 degrees. They couldn't be anything else. If they're all equal to each other, they all 3 have to be 60 degrees. And so if all 3 angles are 60 degrees, we have an equiangular triangle. Now notice, that also means that an equiangular triangle could also be said to be an acute triangle, since all those angles are less than 90. So equiangular triangles are always acute triangles, but not all acute triangles are always equiangular triangles. All right, so there we've classified triangles based upon their side lengths. We can pause here to let you finish writing your notes on that, and then we'll move on and look at a few examples. Okay, so our first question, question A, classify the triangle as acute, equiangular, obtuse, or right. Well, this triangle is definitely an acute triangle, since all 3 angles are less than 90 degrees. It is acute, but it's also equiangular, since all the angles are all congruent to each other at 60 degrees. So it has 3 congruent angles. It's an equiangular triangle, and it's an equiangular triangle, which is also an acute triangle. Here's a second example. Classify the triangles acute, equiangular, obtuse, or right. Well, it's definitely not right. There are no 90-degree angles, so you can throw that one out. It's definitely not acute because this angle is not an acute angle. 130 degrees is more than 90. So while the 30-degree angle and the 20-degree angle are both acute, This one's not acute, so it's definitely not an acute angle or triangle. It's definitely not equiangular since these three angles are not the same measure, but it is an obtuse triangle. It has exactly one obtuse angle, so that's an obtuse triangle. So one angle of the triangle measures 130 degrees, so it is an obtuse angle. The triangle has an obtuse angle, so it's an obtuse triangle. Okay, so here's one for you to do. We can pause right here while you take a second to answer this one. Question from architecture. The frame of this window design is made up of many triangles. Classify triangle ACD. So triangle ACD would be this triangle. And that triangle would be an obtuse triangle because angle ACD is an obtuse angle. So we're talking about an obtuse triangle. And then for question B, the frame of this window design is made up of many triangles. Classify triangle ADE. So let's find triangle ADE. Here's ADE. So that's triangle ADE. And triangle ADE would be a right triangle because angle D, or we shouldn't really call it angle D because there's more than one angle at vertex D. We should refer to it as angle ADE. This angle ADE is a right angle, and so we would classify that as a right triangle. Okay, another example, we're going to classify this as an acute, equiangular, obtuse, or right. Explain our reasoning. Well, when we look at this, we want to classify triangle XYZ. So there's more than one triangle here, so let's make sure we understand exactly which one triangle XYZ is. That would be this one that I'm highlighting. So there's triangle XYZ. So triangle XYZ has three angles in it. And the angle up here at vertex X is a 50-degree angle, which is acute. And over here at vertex Z, we have a 40-degree angle, which is acute. But the angle with a vertex of Y, which is angle XYZ, is made up of two smaller parts, which are 40 degrees and 50 degrees. So angle XYZ is the sum of the 40 and 50-degree angle, which makes that a 90-degree angle. And so angle XYZ is a right angle. And since that's a right angle, we would classify that as a right triangle since it has one right angle. One more example here. Classify triangle ACD as acute, equiangular, obtuse, or right. Well, we don't have any right angles, so it's definitely not right. No 90-degree angles here. We do not have any obtuse angles. We have no angles that are more than 90, so it's not obtuse. All the angles are not the same measure. They're not all 60 degrees, so it's definitely not equiangular. But all three of these angles are all three less than 90, so we do have an acute triangle. Okay, now we're going to look at a different way to classify triangles, and this is going to be based upon the lengths of their sides. And we're going to have three words here that we're going to use. We're going to classify triangles as either, let's start over here on the right-hand side, a scalene triangle. A scalene triangle is a triangle where all three sides have different lengths and no sides are congruent to each other. Now, if we have two of the sides that are equal in length and then a third side that may or not be equal in length, we refer to that as an isosceles triangle. So an isosceles triangle has at least two congruent sides. Now, notice the phrase at least two. Okay, it's possible that it could have three, and if it has three, we could still technically call it an isosceles triangle. It just has to have at least two. It doesn't say exactly two, but just at least two. So if a triangle has at least two congruent sides, we can refer to it as isosceles. But if it has more than two, if it has all three sides are congruent, then even though we technically could still call it isosceles, the better name for it would be the first word here, which is equilateral. An equilateral triangle has all three angles that are congruent to each other. And just as a note here, this we'll see a little later on, if a triangle is equilateral, it turns out that it also has to be equiangular. So if all three of these sides are congruent, then it turns out that it forces all three of these angles to also be congruent. And since all three of the angles are congruent, as we said earlier, that means all three of these angles are all 60 degrees. I know that's very messy and completely unreadable. I'm sorry about that. It's hard to write on this thing. And yeah, the eraser's not working either. Okay, so yeah. So we've got an equiangular and an equilateral triangle. Okay, so we've got a couple of examples to look at here. This frame of this window design is made up of many triangles. Classify triangle ABC. And we're going to classify that in terms of its sides. Well, triangle ABC, it would appear that triangle ABC does have side AC and side BC congruent to each other, but side AB is not congruent. And so we've got two of the sides congruent. If at least two sides are congruent, then we have a triangle that's isosceles. All right, here we have another problem, example number 4 here, classify triangles by sides within figures. So we've got triangle VWX, and then we've got point Y here. It says point Y is the midpoint of VX, and WY is 3, and so WY is 3.0 units. Here's WY, 3 units. And we want to classify triangle VWY. So we're trying to classify this triangle as either equilateral, isosceles, or scalene. Well, since WY we're told is 3, one side of this triangle is 3, and we can see on the diagram that VW is 4.5, it's clearly not going to be equilateral. We can cross that off, since all three sides would have to be congruent for that to happen. It's possible, but we haven't determined yet, maybe segment VW is either 4.5 or 3 units in length that can make it isosceles. The fact that Y is the midpoint of segment VX, though, we know that midpoints divide segments in half. They divide it into two congruent segments. On the diagram, we can see that segment VX is 8.4 units. So segment VY must be half of that length, which would be 4.2 units. Well, so that if this is 4.2 units, and this is 3 units, and this is 4.5 units, no three of those sides are congruent to each other. So in a full explanation here, we can say by the definition of the midpoint, Vx and Yx are congruent to each other. And so that ends up giving me that Vy is 4.2 units long. And that means that all three sides are different. So the triangle is a scalene triangle. Okay, example 4, if point C is the midpoint of BD, then classify the triangle as equilateral, scalene, or obtuse. We want to classify triangle ABC. So triangle ABC, this triangle here. Okay, now if we look at our diagram, we have two segments marked as being congruent to each other already. Segment AB and segment AC are marked on the diagram as being congruent to each other with these tick marks. So if AB has a length of 1.2, then AC would also have a length of 1.2. So far, triangle ABC is at least going to be an isosceles. It's definitely not scalene, since we definitely have two sides that are congruent to each other. We need to figure out what the length of BC is in order to compare it to the other two sides that we do know. And to find BC, we'll use the fact that C is the midpoint of segment BD. And segment BD is just segment BC plus segment CD. If C is the midpoint, then segment BC and CD must be equal to each other in length, which means that each of them is half of 3.4. If we take half of 3.4, half of 3.4 is 1.7. So now comparing the three sides, we can see that we have two sides congruent. We do not have three. So we can eliminate a scalene, we can eliminate equilateral. Triangle is isosceles. All right, let's look at this example. Find the measures of the sides of isosceles triangle KLM with base KL. So here's another word here that we should talk about, the base. An isosceles triangle, if it has two sides that are congruent, we refer to the two sides that are congruent as the legs. So let me just draw a little isosceles triangle here. So an isosceles triangle always has two legs and a base. The legs are the sides that are congruent. So the two legs of an isosceles triangle are always congruent to each other. And then the third side is called the base. And that's the non-congruent side of an isosceles triangle. So when it tells me that KL is the base, that's just kind of an indirect way of telling me KL is the side that's not one of the two congruent ones, which means that KM and LM are the two congruent ones. So it's just kind of a backwards way of telling you that important piece of information. Because what we need to do is we need to write an equation. Since we have algebraic expressions for the sides, we need to write an algebraic equation. And so I need to use some true fact from this diagram to write that equation. And the true fact is that KM and LM are congruent to each other. So that means I can set their lengths equal. So 4D minus 13 must be equal to 12 minus D. Okay, we want to just solve that for the variable D. If I add D to both sides of the equation, I'll get 5D plus 3, plus 13 rather, is equal to 12. And I've messed myself up here because that's a minus 13, not a plus 13. So this should be a minus right here. And I'll fix that on my next step since my eraser part isn't working here. So that's 5D minus 13 equals 12. We'll add 13 to both sides and we get 5D equals 25. Divide both sides by 5 and we'll get D is equal to 5. Well, now that I know that D is equal to 5, the goal here is to find the measure of all the sides. And so now it's just a matter of substituting back in. So here's the equation written out in a little bit neater way so you can see all the steps and also the justification for each step written on the side here. So that's the equation we wrote, and then these are the steps we got to get to D is equal to 5. Now that I know D is equal to 5, now it's just a matter of substituting back in to find the length of each side. So Km is 4D minus 13. Substituting in D is 5 gives me that Km is equal to 7. ML is equal to that length, so ML is also equal to 7. KL is equal to D plus 6, so that's 5 plus 6, which is 11. So the three side lengths, both KM and ML are 7, and KL is 11. Okay, so now a couple for you to do to check your progress. So we'll pause here and let you take a moment and answer this question. Find x if the measure of each side of the equilateral triangle of ABC is these sides given. Keyword here is equilateral. Think about what that means. We'll pause right here and give you a moment to solve this. Okay, so we want to write some sort of an equation, and it turns out there's actually multiple equations we can write here. I know that all three of these sides must have the same length since the triangle is equilateral. So there's more than one equation that I can actually write. I know that AB and BC must be equal in length, so I can write that 6x minus 8 is equal to 7 plus x. I also know that segment BC and AC must be equal in length, so I could write 7 plus x equals 13 minus x. I also know that AB and AC are equal in length, so you can actually write 6x minus 8 is equal to 13 minus x. So it doesn't matter which one of these three you decided to write and solve, you should get the same solution for all three. And that solution is that x is equal to 3. And substituting 3 back into all three expressions lets you see that all three sides have a length of 10. Okay, so that concludes the lesson. We'll stop here and we'll move on into doing some problems.